How did ancient Egyptians build the Great Pyramid without cranes, trucks, or lasers? What secrets did they take to the grave, literally? For centuries, we've imagined slaves hauling stones and pharaohs barking orders. But new clues suggest something far more advanced. From forgotten sciences to tools erased by time, the truth may change everything you think you know. Stay until the final chapter. We reveal the most controversial theory hidden in plain sight. But before we dive in, let me know if you're enjoying this kind of long, gentle history. Feel free to tap that like button and subscribe, only if you truly love what I'm doing here. And in the comments, share where you're tuning in from and what time it is in your city. I always love seeing our little bedtime crew gathering from every corner of the world. Now lower your lights, maybe let a soft fan hum in the background, and settle in. Let's ease into tonight's quiet journey together. Chapter 1: The Quarry Code, How Stones Were Moved Without Wheels. Deep in the southern quarries of Aswan, under the unforgiving Egyptian sun, lie clues that defy everything we think we know about how the Great Pyramid was built. Here, scattered across red granite bedrock, massive blocks rest half-carved and abandoned, like someone just walked away mid-task thousands of years ago. These are no ordinary stones. They're the same pinkish granite used for the pyramid's inner chambers, each weighing up to 70 tons. But these quarries are over 500 miles from Giza. No wheels, no trucks, just solid rock. So how were these titanic stones carved, lifted, and then transported that far without modern technology? What secrets lie in the strange, circular indentations in the granite and the patterns that seem to follow no obvious logic? To understand how the ancient Egyptians achieved this impossible task, we must begin not at the pyramid itself, but at the source of its bones. The quarry holds answers, but only if you know where to look. The first mystery lies in the marks themselves. All over the Aswan quarries, granite blocks show deep round holes, worn smooth as if shaped by rotation rather than blunt force. Unlike the straight, chiseled cuts we associate with primitive tools, these holes look like someone drilled through solid rock with a spinning device. But no such tool from the Old Kingdom has ever been recovered. These marks don't match copper chisels or pounding stones. They suggest a method lost to time, a technique that didn't just chip away at rock, but shaped it with astonishing control. Some archaeologists believe these may have been made using tubular drills with an abrasive slurry, perhaps quartz sand or crushed stone mixed with water. But the precision, the depth, the smoothness, none of it fits neatly with what copper tools should be capable of. It's almost as if the quarrymen had access to a cutting method just advanced enough to seem impossible, yet primitive enough to leave behind no machinery. Equally baffling is the choice of material. Granite is one of the hardest natural stones on Earth. Even today, carving granite requires diamond-tipped saws and industrial pressure. Yet the pyramid's builders used it extensively, for the king's chamber, for massive portcullis blocks, for architectural features buried deep inside the core. Why not use limestone, which was more abundant, easier to cut, and already used for the pyramid's outer casing? There must have been a reason. Granite wasn't just decorative. It was functional, structural. The builders went through unimaginable effort to retrieve it from a quarry hundreds of miles upriver, carve it, transport it, and install it with such precision that the gaps between blocks are almost invisible. So the next question becomes more haunting. How did they move it? And why go to such lengths for material that defied their known tools? These questions point toward an engineering mindset far more advanced than we're often taught. What if the answer wasn't in the quarry or the chisel, but in the Nile itself? Every year, the river flooded, rising over the banks and sweeping through the land. Most see these floods as destructive, but the ancients saw opportunity. What if they used the Nile not just as a water source, but as a tool? Imagine waiting for the flood season, when the river was high and the quarries near the water's edge were submerged. Picture a team of engineers timing the carving of a block to coincide with the rising waters. As the block was cut, buoyancy could be used to help lift it from the quarry floor. Stones may have been floated, partially or fully, onto makeshift wooden platforms, lashed together and guided by ropes. Instead of dragging stones across sand, they were navigating them along a hidden highway that nature renewed every year. The Nile wasn't a barrier, it was a conveyor. This theory gains more weight when we consider the network of canals that once fed into the Nile's main channel. Some researchers believe that artificial basins were dug near the quarry, designed to trap floodwaters at just the right levels. If this is true, it would mean that Egypt's engineers didn't just build with stone, they engineered water itself. Stones could be floated into canals, moved toward larger barges, and then ferried downriver with the current. It sounds like science fiction, but ancient wall reliefs depict massive boats carrying obelisks and blocks. Though often dismissed as ceremonial, what if they were accurate technical illustrations? Once again, the technology didn't need to look modern to be brilliant. The idea of manipulating water levels to move 70-ton blocks isn't magic. The strategy, it's adaptation. It's proof that the builders weren't just laborers, they were problem solvers. But floating a 70-ton block isn't as easy as dropping it on a raft. Weight distribution matters. The water has to be deep enough, the balance exact, or the barge tips and sinks. That's where another layer of brilliance emerges. Some believe that the stones weren't transported whole, but encased in buoyant wooden frames. These frames, sealed and wrapped, may have worked like modern pontoons, distributing weight and helping the stones stay afloat even in narrow canals. As the floods receded, the water levels dropped, and the stone-laden platforms could be maneuvered onto dry land. From there, short-distance land movement took over. But the bulk of the heavy lifting literally was already done by the river. This kind of seasonal timing requires not just tools but calendars, knowledge of rainfall patterns, precision, which means the builders weren't working randomly. They were working with a system. Interestingly, some stones in the quarries show signs of incomplete cuts, abandoned mid-process. One popular theory is that these were test blocks or had defects. But another possibility is far more revealing. Perhaps the quarry teams were rushing against seasonal changes. If the Nile floods were their window for transport, they only had a limited time each year to cut, lift, and float the stones. Miss that window and the block would be stranded until the next flood cycle. Abandoned blocks may not indicate failure. They may be evidence of a tightly orchestrated logistical chain where timing mattered as much as strength. These were not slaves swinging hammers in chaos. These were coordinated teams, moving with nature's rhythms, executing engineering feats that required foresight and collective precision. Then there's the question of stone softening. Legends passed down through generations speak of a plant-based liquid that could soften rock. While it sounds like myth, certain experiments have shown that organic acids can alter the surface of limestone. Granite, however, is much tougher. But what if the round holes in the quarry weren't just mechanical? What if they were chemical, poured into grooves and left to seep? Acidic compounds might have slowly eroded the stone's molecular bonds. When paired with vibration or percussion, the stone could be fractured cleanly without brute force. There's no direct proof of this technique, no ancient recipe, but nature holds secrets, and civilizations long past had time to experiment. Plants, minerals, oils. What we see as legend may simply be misunderstood science. The method is lost, not disproven, and the evidence is waiting in those strange circular holes. Even more perplexing are the polishing marks. Some granite blocks at the pyramid site are so smooth, they reflect sunlight. And yet, we see no polishing tools from that era advanced enough to produce that finish. How did they do it? Some suggest they used sand and repetitive motion, but the labor required would be staggering. Others point to the use of large abrasive stones. But there's another idea: vibrational finishing. If the ancients understood resonance even at a basic level, they could have used oscillating platforms or hand tools to shake sand particles at high frequencies, wearing down rough edges faster than brute grinding. Think of it like an ancient vibrating sander, only human-powered. Again, no devices survive, but the polish remains. Something refined those surfaces beyond what copper tools alone could achieve. Whatever the method, it speaks of a workshop mind, not a brute force labor camp. We also cannot ignore the social structure behind this operation. Moving granite over 500 miles wasn't just a technical challenge. It was a logistical miracle. Coordinating labor, supplies, schedules, tools, and seasonal changes across that distance required more than muscle. It required leadership, planning, and communication. We see evidence of centralized command, perhaps even specialized guilds of quarrymen, transporters, and builders working in harmony. This wasn't a haphazard process. It was an economy centered on engineering. If the quarries were the skeleton of the pyramid, then the Nile was its bloodstream, and the labor force was the muscle guided by a central mind. That structure alone suggests a society far more organized and technologically aware than traditional history admits. And so we circle back to the question, how were these stones moved without wheels? The answer isn't a single invention. It's a system, a blend of seasonal timing, forgotten chemistry, buoyancy physics, and resourceful labor. The builders didn't need advanced machines. They had the Nile. They had knowledge. They had time. And that might be the most unsettling realization of all. The evidence was never missing. It was just misunderstood. In the next chapter, we move from the river to the desert, where even more ingenious techniques awaited, rolling without the wheel and sliding without friction. The stone's journey was far from over. The deeper we dig, the clearer the ancient code becomes. Chapter 2: The Desert Conveyor Rolling Without the Wheel. Once the stones left the Nile, the next phase of their journey began. And this leg may be the most underrated miracle of all. Imagine hauling a 70-ton granite block across miles of desert with no wheels, no cranes, and no diesel engines. The ground is dry, the air burns your skin, and the sand seems endless. Most would imagine slaves dragging stones with ropes, groaning beneath the strain. But the truth may be much more ingenious. In temple walls and ancient carvings we find hints. Figures pulling sleds while others pour water before them. A strange detail easily dismissed. But this small act may have unlocked a physics trick forgotten for millennia. Because what if the secret wasn't brute force, but reducing friction itself? The desert, once seen as an obstacle, may have been transformed into a conveyor, a machine of sand, clay, and human coordination. And it worked, because the pyramid still stands. The clue lies in that image of water being poured on sand. At first glance, it seems symbolic, but modern experiments have confirmed something remarkable. Slightly wet sand dramatically reduces friction, allowing heavy sleds to slide with far less resistance. Dry sand scatters and forms ridges, but damp sand clumps together, forming a cohesive track that supports weight and minimizes drag. The physics is real. The ancients didn't need roads. They made them temporarily on demand using what they had: water, sand, and muscle memory. Tests show that pouring just the right amount of water in front of a moving sled can reduce the pulling force by over 50%. In a world without wheels, that kind of advantage isn't trivial, it's revolutionary. And it suggests something profound. The builders weren't just working hard. They were working smart, using desert terrain as a dynamic system that helped rather than hindered their progress. But that's only the beginning. Researchers examining drag marks on ancient sled paths found they weren't random. They followed consistent widths, depths, and spacing, suggesting controlled routes, not chaotic movement. The layout may have functioned like a dryland railway. Stones weren't just dragged aimlessly. They were moved along planned corridors, packed with clay, possibly lined with planks or even reeds to reinforce the ground. These paths may have been temporary but highly effective. And if the sand was too loose, they may have added crushed stone or organic binders to firm up the track. In effect, the desert became modular, changeable, custom-built. It's not just engineering, it's improvisational mastery on a massive scale. Like building highways that vanish when the job is done, leaving almost no trace behind except grooves in hardened earth and a pyramid standing far away. And then come the cradles. Some granite blocks at Giza show subtle where marks not on their bottoms, but along their sides, suggesting they may have been held or wrapped. One theory proposes the use of wooden frames or log cradles designed to surround the stone and distribute its weight across multiple contact points. These cradles could be fitted with rounded undersides, essentially acting like ancient sled runners. Combined with lubricated sand and moisture, these runners may have glided over the ground with surprising ease. And here's where it gets even more interesting. These cradles may have rotated. A few scholars suggest that the Egyptians created partial cylinders from bent logs, placed under the cradle and rotated by teams in rhythm. Not wheels, but close. These makeshift rollers didn't turn on axles, they were rolled in sequence under the block. Crude, yes, but repeatable, effective. Enough to move mountains one block at a time. Other accounts hint at log-based sleds with carved tracks. These weren't sleds in the winter snow sense, but platforms with slight grooves underneath, matched to wooden rails or rolling paths. The logs would be placed in sets, with the sled-pulling crew moving them forward as the block advanced. An ancient version of continuous rolling. Think of it as a land treadmill powered by humans. And again, water comes into play. By coating the logs or tracks in clay slip, a mix of water and fine earth, the friction drops even further. The logs absorb the liquid, becoming slick and making the movement smoother. This wasn't just a single technique, it was a multi-layered process. Adjusted daily, tuned to the weight of the block, calibrated by teams who likely memorized the desert's pulse. The sand may shift, but the memory of movement does not. It passed down, worker to worker, like choreography in an ancient ballet of labor and ingenuity. This entire operation required coordination, not just strength. Hundreds, maybe thousands of workers had to know their role at every step. Some pulled ropes, others poured water. Still more monitored sand conditions or reset the logs ahead of the path. It would have looked chaotic to the untrained eye, but it was a dance. Each block moved in rhythm with the desert. In many ways, the pyramid wasn't just built from stone. It was woven from motion, a symphony of friction management, timing, and terrain manipulation. These techniques weren't documented in writing, perhaps deliberately. They lived in the hands of those who used them. The tools left no trace because the tools were knowledge, not objects, passed through demonstration, not scrolls. And when the last generation of builders faded, the desert buried their secrets beneath wind and silence. What's even more haunting is how little remains. Unlike temples or statues, these sand tracks and wooden devices disappeared. Erosion erased the evidence. Wind smoothed the scars. All we have are the pyramid's blocks and the vague outlines of ancient roads occasionally visible in satellite images. But those images reveal something powerful. Trails that cut across the desert in straight lines and gentle curves, aligning precisely with pyramid sites. Some believe they were ceremonial roads. But what if they were the conveyor belts of ancient industry? Not roads to honor the gods, but highways for stone. These routes suggest planning, not for travelers, but for freight, for motion, for mass transport under the harshest conditions on Earth. Even without wheels, they moved millions of tons. That alone demands we reconsider what ancient really means. Another forgotten detail lies in the idea of modular teams. What if instead of one massive crew moving every stone from quarry to pyramid, there were relay stations, specialized groups responsible for one segment of the journey, handing off the block to the next team like runners in a race? It would explain the consistency in movement and the absence of full-length pathways. Each section optimized for its own geography, some on water, some on clay, some on sand. These weren't just transport teams. They were units of an ancient logistical network. And they may have included specialists, sand tamers, rope handlers, moisture controllers. Each block may have passed through a dozen hands before reaching the pyramid base. It wasn't just manpower, it was project management. Evidence of a civilization that understood not only materials but systems. One of the most mysterious elements is how they dealt with terrain changes. The Nile floodplain is flat, but once the path reaches the highlands toward Giza, the elevation rises. Yet there is no clear sign of graded ramps or massive embankments stretching for miles. How did they overcome this slope? Some theories suggest the blocks were temporarily stored in holding pits during the flood season, then moved only once conditions were perfect. Others argue that sand itself was the solution. By building up temporary berms and packing down layers, the builders created flat, artificial platforms leading gradually upward. These berms would be stripped away after use, returning the desert to its natural state, like scaffolding made of earth itself, reusable, biodegradable, and nearly invisible once dismantled. The desert became a construction material, formed, used, and erased as needed. We often overlook how silence can be a kind of evidence. There are no records of the desert conveyor because it left no monuments, but its effectiveness is carved into every stone that made it to Giza. The absence of wheels isn't a flaw, it's a clue. They didn't need wheels because they had something better. An adaptable, terrain-based system that used the environment as a partner, not an enemy. The real genius wasn't in inventing new technologies. It was in maximizing what already existed. Moisture, sand, gravity, and wood. The natural elements became engineering tools in the hands of masters who understood balance and force without formulas. They didn't build the pyramid with machines. They became the machine. As we step away from the scorching desert and closer to the base of the pyramid itself, the final challenge comes into view: lifting the stones. Not once, not twice, but again and again, some placed over 100 feet in the air. How could bare hands raise such mass without pulleys, cranes, or scaffolds that towered above the monument? In the next chapter, we dive into a lost lifting system that used only one material: sand. A system so simple it disappears beneath your feet. So clever, it may have been the invisible elevator of the ancient world. The mystery deepens, but the code continues to unravel. Chapter 3: The Sand Jack Theory, lifting 70 tons with bare hands. Standing at the base of the Great Pyramid, one question looms larger than any stone block. How did ancient builders lift 70-ton slabs dozens of feet into the air with nothing but ropes, wooden sleds, and bare hands? As the walls rose, the challenge grew. Moving stones horizontally was hard enough, but raising them vertically required a different kind of genius. Here lies one of the most overlooked yet plausible theories of ancient engineering: the sand jack method. Imagine using nothing more than sand, gravity, and carefully controlled release of pressure to incrementally lift immense stones, like an invisible elevator.
No cranes, no pulleys, no toverem scaffoldsos.
Just the subtle power of shifting grains. This chapter explores the possibility that the builders harnessed a deceptively simple principle, turning the very desert beneath their feet into a lifting device capable of feats modern engineers still marvel at. To understand how sand could lift a stone, picture a large wooden box built to hold a block. Underneath this box sits a pit filled with sand. The stone rests on the box. As workers slowly remove sand from beneath, the box sinks under the stone's weight, lowering it with control. But reverse the logic. If you add sand beneath the box, the rising level pushes the box and stone upward, millimeter by millimeter. By controlling the sand's volume and flow, workers could raise or lower massive weights with surprising precision. This is the essence of the sand jack. It operates on the principle that sand behaves almost like a liquid under pressure. It can flow, settle, and bear tremendous weight, but also release that weight gently if drained carefully. Ancient builders may have mastered this principle, creating temporary sand lifts capable of raising stones higher than any ramp could reach efficiently. Evidence supporting this idea comes from the pyramid's very architecture. Gaps between blocks are minimal, and horizontal layers are impressively level, even dozens of courses up. This precision suggests a system that allowed fine adjustments during placement, not just brute hauling. Sand jacks would have given workers the ability to correct a block's position by raising or lowering it subtly until it aligned perfectly with its neighbors. Rather than risk shifting stones from ramps or scaffolds, builders could prepare stone platforms supported by sand, raise them to the desired level, and maneuver each block into place with unparalleled control. The process would have been slow, but the pyramid took decades to build. Time was abundant, precision was priceless, and sand was everywhere. The solution was literally underfoot. Skeptics argue there's no direct evidence of sand jacks in ancient texts or artifacts, but absence of proof is not proof of absence, especially for perishable wooden frames or sand pits that would leave few, if any, traces after thousands of years. What we do have are hints in ancient bas-reliefs showing platforms, blocks, and workers performing tasks that don't match simple ramp pulling. Some images depict workers standing atop partially constructed walls, as if operating mechanisms rather than merely dragging ropes. While speculative, these depictions align with how sand jacks would have functioned. The technology wouldn't require exotic materials or metallurgy beyond what the Egyptians already had. Wooden boxes, woven baskets, or clay bins could easily contain sand. Controlled release would be as simple as opening a hatch or pulling plugs to let sand flow out gradually. Consider the mechanics of construction sequencing. With sand jacks, teams could build multiple lifting stations along the pyramid's perimeter. Each station would raise stones independently, reducing bottlenecks. Workers could add sand to lift a block slightly, slide it horizontally onto a weighting surface, and repeat the process course by course. This decentralized lifting approach would have allowed simultaneous stone placement on different faces of the pyramid, accelerating construction and balancing weight distribution as the structure grew. By synchronizing multiple sand jacks, engineers could keep the pyramid level on all sides, explaining the consistent flatness of each layer despite the massive scale. This kind of coordination points to an organizational complexity far beyond the image of chaotic slave labor. Another intriguing clue comes from the distribution of crushed limestone debris found around the pyramid base. Some archaeologists believe this debris resulted from ramps being dismantled. But what if part of it came from sand jack pits being filled in or leveled after use? Once a block reached its final position, the sand pit beneath would become obsolete. Workers could simply spread the sand and crushed stone around the site, erasing much of the evidence while simultaneously building up the pyramid's plateau or smoothing work areas. Over time, wind and erosion would blend these deposits into the landscape, masking any traces of pits or temporary wooden structures. The very efficiency of the sand jack system may be why it vanished without a clear archaeological footprint. Modern analogies bolster the plausibility of this theory. In certain traditional construction techniques still used in parts of the world, villagers lift entire houses or vehicles using bags of sand or gravel, adjusting levels incrementally by adding or removing material. The physics hasn't changed since ancient times. What has changed is our willingness to imagine the ancients applying such methods on a monumental scale. Many engineers dismiss sand jacks as too slow or cumbersome, but for a project measured in decades rather than years, speed was less important than precision and safety. A block raised by fractions of an inch per hour, if done day and night by rotating teams, would rise feet over days, enough to keep up with pyramid construction timelines. The beauty of the sand jack theory lies in its minimalism. There is no need for advanced metallurgy, complex gears, or lifting beams taller than the pyramid itself. It requires only basic materials: wood, sand, and human labor, combined with meticulous planning and patience. And yet, the results rival those of modern cranes. This approach would also minimize the danger of catastrophic failures. A ramp collapse could send stones crashing down, killing workers and damaging construction. But with sand jacks, each block moved within a controlled vertical shaft, protected on all sides. Even if something went wrong, only that station would be affected, not the entire project. Safety through compartmentalization, a strategy modern engineers still use in risky projects today. There's also the question of alignment. The pyramid's orientation to true north is within a fraction of a degree, a feat nearly impossible if heavy stones were being hauled and dropped into place without fine control. Sand jacks would have allowed micro-adjustments during final positioning, rotating or sliding a block by centimeters until perfectly aligned. Combined with copper chisels and leveling tools, this method could account for the incredible uniformity of courses across the pyramid's massive faces. Sand jacks didn't just lift, they guided. They turned placement into an art form, each block a precisely tuned piece in a colossal stone symphony. This level of care suggests a workforce trained not only in brute labor, but in technical craftsmanship. Some theories propose sand jack variations using hollow clay cylinders filled with sand, stacked beneath the stones like giant syringes. By removing sand sequentially from each cylinder, builders could control tilt as well as height, ensuring blocks landed perfectly flat even on slightly uneven surfaces. While speculative, experiments with replicas show that clay tubes filled with sand can indeed bear enormous weight and allow gradual descent when emptied. Whether or not Egyptians used this exact design, it demonstrates how sand, so often overlooked, can perform mechanical tasks usually reserved for iron or steel. The ancients may have discovered these tricks through trial and error, passing techniques from master builders to apprentices until the knowledge became second nature. The sand jack theory also fits cultural patterns of secrecy. In many ancient societies, trade secrets were guarded fiercely, shared only within families or guilds. Methods that gave one group an advantage could mean wealth, power, and prestige. By keeping the true lifting technique unwritten and taught only through demonstration, knowledge would remain exclusive and secure. Over generations, the memory of the sand jack could fade as families died out or political upheaval disrupted guilds. By the time later dynasties looked back at the pyramid, the method may have already been lost. What remained was a monument so perfect, it defied explanation. A puzzle that still teases us today. As we leave behind the shifting sands of these lost elevators, another mystery rises to greet us. If sand jacks helped place the stones, what guided their ascent across the growing pyramid? The ramps long debated by historians are not as simple as single straight paths. They may have twisted, turned, and spiraled in ways we have yet to fully understand. The next chapter uncovers the lost ramp systems. Multiple ramps, hidden designs, and engineering so advanced it still confounds archaeologists. The code of the pyramid continues to unfold, one layer at a time. Chapter 4: The Lost Ramp System, and not just one ramp, but many. The mystery of how the massive stone blocks were lifted to the upper tiers of the Great Pyramid has haunted engineers and historians for centuries. Traditional theories often rely on the idea of a single colossal ramp stretching outward for miles. But this concept quickly collapses under the weight of logistics. The sheer volume of materials required to build such a ramp would rival the pyramid itself. There would be no evidence of such a massive structure surviving the millennia, yet nothing of the sort remains. That absence leads us down a different path, one where multiple ramp systems work together in a symphony of ancient engineering. These were not singular constructions, but temporary, adaptable networks, spiraling, zigzagging, and folding into the pyramid structure itself. possibly disassembled or repurposed as the pyramid rose. Rather than one ramp dominating the desert, a hidden choreography of interlocking pathways may have danced around the rising monument like veins on living stone. Archaeological clues to this theory come not from the obvious, but from the overlooked. On the sides of many unfinished pyramids, subtle traces remain. Indentations in limestone, ledges without apparent purpose, and platforms that don't fit ceremonial explanations. These could be the echoes of once functional switchback ramps, hugging the structure like scaffolding on a skyscraper. Some Egyptologists have also noted curious notches and inset grooves around the pyramid's lower courses. These features might have supported the timbers and anchor points of angled ramps, ones that climbed not directly upward, but in a zigzag pattern along the faces. In this scenario, ramps were modular, movable, and designed for precision. A ramp would rise alongside the stone courses, anchored at various levels, then be dismantled and reconfigured further up. Instead of a brute force solution, this was a flexible, intelligent system, one tailored to the constraints of space, gravity, and manpower. An internal ramp theory has gained momentum in recent years, proposing a completely different mode of construction. According to this idea, the pyramid concealed a spiraling corridor within its walls, a kind of hidden helix winding upward just beneath the surface. This corridor would have been wide enough to allow stones to be pulled upward on sledges, but narrow enough to avoid detection without invasive scanning. Some modern scans of the pyramid have revealed thermal anomalies and internal voids, consistent with the presence of such passageways. These internal ramps would have protected the construction process from wind and weather, allowed work to continue regardless of external conditions, and hidden the method itself from enemies or rival kingdoms. They could even explain the strange patterns of wear and load-bearing stress observed in certain sections of the pyramid. If true, this theory means the pyramid was not just a monument, it was a machine built to build itself. A vertical shaft theory adds another layer to the mystery. While much focus has been given to horizontal and sloping paths, what if the real secret lies in vertical lifting chambers? Picture a deep central shaft rising from the pyramid's core, filled gradually with sand, rubble, or timber as platforms moved upward. Teams could have operated a lifting mechanism inside, slowly raising blocks from one level to another in stages. This vertical route might explain the Grand Gallery's strange design, with its steep incline, corbelled ceiling, and narrow channels, features not easily explained by ritual or symbolic function. The gallery may have acted as a massive internal hoist, a corridor for counterweight systems, or even a channel for stone transport through pulleys and levers. Vertical lifting was not beyond the ancients. They understood balance, pressure, and mass in practical ways that modern theorists often underestimate. Such a shaft would also leave little trace, buried inside the heart of the structure. There is growing speculation that the pyramid's own geometry may have dictated the ramp system's layout. Ancient architects may have embedded the movement paths into the very angles of the pyramid's faces, using a mathematical framework we've yet to fully decode. By plotting block positions in advance, ramps may have been built along projected lines of force and stress. The corners could have anchored spiral stair ramp hybrids, while recessed edges allowed for switchbacks with resting ledges. Each course of stones wasn't just a layer but a platform for staging further movement upward. In this interpretation, the pyramid was designed from the beginning as a climbing engine, a rising framework that shaped and enabled its own growth. Nothing was left to chance. Every stone, angle, and void had purpose, not symbolic but mechanical. It was a system of construction where architecture and engineering were indistinguishable. Support for this multi-ramp hypothesis also comes from worker graffiti found in pyramid complexes. Some markings appear to indicate teams, sections, and levels, not just names or prayers. These could have functioned as construction codes, guiding workers to specific zones where ramps and blocks intersected. One side team may have worked the east-facing spiral, another the internal switchback, and still others on vertical lifts. It resembles a coordinated assembly line rather than chaotic labor. This kind of operation would demand remarkable planning, rotating crews, overlapping pathways, timed lifting schedules. The system had to be seamless or collapse entirely. And yet, the precision of the final result suggests success. The pyramid wasn't built in haphazard layers, but with astonishing symmetry and alignment. Such organization implies more than physical might. It implies a blueprint, a logistic strategy, and perhaps a central command center unknown to us today. Erosion and time may have erased many of the physical traces of these ramps. Most would have been temporary, constructed of mud brick, limestone chips, or timber, materials easily repurposed or destroyed. Desert winds scoured the softer components away, while stone was cannibalized for later projects. What remains are only the subtlest scars, the shallow ledges, the broken edges, the strange asymmetries. Some pyramids, left incomplete, still show ramp foundations rising a third of the way up before abruptly stopping. These are not errors. They are frozen mid-motion, construction paused at a moment when the ramps still embraced the structure. They serve as ghostly blueprints, clues to the larger system that once surrounded the Great Pyramid in scaffolding, ramps, and platforms. Like bones without flesh, they hint at an architecture within the architecture, a skeleton of motion once wrapped around the stone skin. Comparative archaeology adds another piece to the puzzle. In Mesopotamia, ziggurats were built with spiral ramps climbing the outside. In South America, Incan stonework shows evidence of inclined planes used for movement. Even in ancient China, massive earthworks were constructed using layered, ascending platforms. Across the ancient world, the concept of multi-tiered construction seems to have arisen independently, suggesting it was not beyond the capability of the pyramid builders. What makes the Egyptian version unique is its scale and concealment. Unlike other civilizations that left ramps intact or visible, the Egyptians seem to have absorbed their building process into the pyramid's rising form. Their ramps did not survive because they were never meant to. They were consumed, like scaffolding absorbed by a living organism, leaving behind only the final result: smooth faces, hidden interiors, and enduring silence. The limitations of modern assumptions often blind us to what may have been right in front of us. We imagine ancient builders struggling with ropes and brute force, forgetting they were also master organizers, astronomers, and engineers. They observed cycles of the sun, tides of the Nile, and seasonal winds. They understood leverage, balance, and sequencing. The idea that they would rely on one ramp for such a monumental task underestimates their ingenuity. Instead, multiple ramps, some external, some internal, some vertical, formed an adaptive toolkit. They did not build up in a straight line. They wrapped their engineering in layers, moved through spirals, counterbalanced forces, and reassembled the path as needed. This was not chaos. It was choreography, a construction ballet frozen in limestone. The genius of the multi-ramp system lies in its invisibility. It explains both the pyramid's perfect form and the absence of construction debris. Ramps were absorbed, recycled, or destroyed as the monument rose. What we see today is the clean version, the completed product, not the factory that built it. The ramps were never meant to survive the process. Like the scaffolds of a stage set, they disappeared before the curtain rose on the final structure. Only the pyramid remains, its surface whispering of a process far more dynamic than simple hauling. Each layer is a footprint of vanished ramps, echoing with the sounds of shifting stone, moving teams, and the constant upward crawl of civilization's most enduring mystery. Modern experiments have begun to replicate some of these theories with surprising results. Scale models using internal ramp spirals, modular sled lifts, and sand lifting mechanisms have all proven workable, if slow. These tests show that even without modern tools, the ancients could have achieved the seemingly impossible by distributing the labor across multiple vectors. It wasn't about finding one perfect method, it was about creating a flexible system that worked in concert. Ramps, pulleys, shafts, sand platforms, and human coordination formed a symphony of upward motion. When viewed this way, the pyramid is no longer a static monument. It is the fossil of a massive ancient construction machine. Its final form is awe-inspiring, but its lost process is perhaps the greater wonder, a mystery not just of shape, but of movement. Chapter 5: The Anti-Gravity Sound Experiment, Myth or Forgotten Science. Beneath the crumbling temples of Egypt lie forgotten chambers, their walls etched with curious symbols and instruments that no longer serve an obvious purpose. These rooms were not just places of worship or burial. They were acoustic chambers, designed to resonate with specific frequencies. In certain temples, long corridors end in niches shaped to bounce echoes in strange patterns. The sound inside them behaves unnaturally, growing stronger rather than fading. For centuries, these anomalies were dismissed as coincidence or architectural quirks. But a growing theory suggests that ancient builders may have used sound in ways that defy our understanding. Not as music or language, but as a force, a tool. One that could move, vibrate, or even levitate stone. This possibility is not just the stuff of legend. Across multiple continents, cultures speak of sound lifting objects, reshaping matter, and opening gates. Could the ancients have discovered a physical principle we are only now beginning to rediscover? Imagine a row of workers chanting in unison, their voices calibrated not for rhythm but resonance. Behind them, stone blocks tremble slightly, as if touched by invisible hands. Near the Tibetan plateau, travelers once reported monks levitating stones with horns and chants. While modern science scoffs at these tales, they persist. Egyptian legends too hint at priests using voices and tuned tools to manipulate matter. Some fringe theorists believe these traditions are remnants of a lost science, an acoustic technology using frequency to alter physical reality. Today, acoustic levitation is real, albeit in small laboratory settings. Scientists can suspend particles using sound waves alone. Yet, scale remains the barrier. What if the ancients had a workaround? By harnessing the geometry of their chambers, aligning frequencies, and orchestrating mass vibrations, they might have accomplished what seems impossible. Not through mysticism, but a form of physics expressed in symbols and ritual rather than formulas. Even the tools left behind suggest something more. In certain tombs and temples, oddly shaped rods made of unknown alloys have been found. Some resemble tuning forks, others more like resonant bars. None appear suited for carving stone, but many show signs of sonic wear, microfractures consistent with repeated vibration. Some were buried near statues that, when tapped, emit clear, bell-like tones. These were not tools of brute force, but instruments of precision, possibly designed to interact with specific materials. It is theorized that when these tools were struck or vibrated, they generated frequencies tuned to the molecular structure of the stone. Not to cut, but to weaken cohesion, causing the rock to split cleanly or even float briefly under pressure differentials. While modern science has not replicated this at scale, it has observed similar effects on a microscopic level. The resonance of quartz under certain frequencies can indeed produce levitation. What if pyramid stones held similar properties, known only to those who laid them? The ancient builders may have understood sound not as mere noise, but as energy. Harmonics, overtones, and wave interference would have been as real to them as pulleys and levers. In the hypogeum of Malta, a subterranean temple aligned with acoustic perfection, whispers can be heard from chambers far away. Sound travels not just linearly, but omnidirectionally, bending through tight stone corridors. Some speculate the Great Pyramid itself was not only a tomb or monument, but an acoustic machine. Its internal shafts, granite beams, and chamber dimensions seem engineered to channel vibration. When wind passes through these spaces, it produces deep, humming tones, almost like the tuning of a vast instrument. If the pyramid could harness ambient sound, or the voices of a synchronized workforce, its core could have become a resonant amplifier. This may have created pressure zones strong enough to help shift massive blocks, either vertically or horizontally. The idea grows more compelling when considering the materials. Granite, used in the king's chamber, is high in quartz, a crystal known for its piezoelectric properties. Under stress or vibration, quartz generates electric charge. In reverse, it responds to electric impulses by vibrating. Today, quartz is essential in watches, radios, and computers for its ability to control frequency. What if the ancients exploited this not electronically, but acoustically? By placing quartz-heavy stones in harmonic locations, they might have activated self-resonating platforms. Such platforms would not lift stones like sci-fi anti-gravity beams, but they could reduce friction, shifting weight balance, or causing heavy stones to temporarily lose effective mass. Combined with levers or sand jacks, this could dramatically reduce the labor needed to move multi-ton blocks. In this light, acoustic levitation becomes not myth, but a component of a multi-system construction strategy blending sound, geometry, and material science. Evidence of this theory also lies in Egypt's silence, quite literally. Despite the Great Pyramid being the largest and most mysterious of ancient structures, no murals depict its construction. No texts detail its engineering. It is as if the method itself was a guarded secret, hidden not from enemies, but time. Yet, clues may linger in ceremonial rites. Priests of old would chant at dawn, their voices directed toward obelisks or statues. These rituals, once thought symbolic, now appear acoustic. The repetition, tone, and rhythm all mirror what modern researchers use when studying resonance. In one instance, a temple in Karnak shows priests striking massive stones with curved rods. The contact points light up with wear, yet leave no tool marks, only sonic impressions. These overlooked details, when seen through a scientific lens, point to a system of work where vibration replaced brute force, and sound was more than speech. It was function. Across the ancient world, from the Andes to Angkor, megaliths bear markings of a technique lost to time. Some stones are fused together so tightly that even a razor blade cannot fit between them. Others curve in odd shapes, seemingly molded rather than carved. In Pumapunku, Bolivia, H-shaped blocks appear cut with machine-like precision, yet the local mythology speaks not of blades, but of sound. According to these traditions, music and tone allowed the stones to rise. Similar accounts come from India, where certain temples are said to have been constructed with the help of vibrations. While archaeology has yet to validate these tales, they persist across cultures separated by oceans and millennia. The pattern suggests more than coincidence. Perhaps ancient humanity once shared a unified understanding of acoustic power, passed through oral tradition, ritual, and architecture, now buried beneath layers of skepticism and sand. Skeptics argue that no clear ancient texts describe sound being used to lift stone. But this assumes that knowledge must be recorded in the way modern science demands. Ancient knowledge was embedded in symbol, myth, and practice. The Egyptians revered Ma'at, balance and harmony, not just in morality, but in physical systems. Harmonic resonance may have been part of their worldview. To encode technology in myth was not deception, but preservation. The builders might have known that stone and vibration are tied by invisible laws. They would not explain this with blueprints, but with allegory, gods who speak creation into being, sacred sounds that awaken life. It is in these stories that the scientific truth may have been wrapped, waiting to be heard again. In this context, anti-gravity becomes less a miracle and more a misinterpreted metaphor for manipulating mass through balance, sound, and rhythm. The Great Pyramid itself seems acoustically alive. The King's Chamber reverberates at a deep frequency of around 440 Hz, a tone close to the human voice's natural pitch. Researchers have found that speaking or singing within the chamber triggers standing waves, vibrations that sustain themselves. If the room is filled with coordinated voices or sounds, the energy intensifies. It is not difficult to imagine ancient priests or engineers standing within these spaces, tuning their chants to the walls. With quartz-laden granite echoing back, the chamber may have become a generator of pure, focused resonance. Whether this resonance was used to heal, elevate, or construct remains unknown. But it is clear the pyramid was not silent. It sings, and what it sings may hold the key to one of history's greatest secrets. Other ancient structures support this theory. The Osirian at Abydos is a mysterious site, sunken below ground level, built with massive blocks unlike anything around it. Its design echoes acoustic architecture. Water once flowed nearby, and some suspect the constant flow provided a low-frequency hum, an environmental background note. Combined with human sound, it could have created sustained vibrations across the structure. These vibrations, if properly harnessed, might have affected the stones laid within or lifted nearby. Acoustic experiments today show that coupling sound with fluid environments enhances vibration effects. Perhaps ancient engineers combined flowing water, temple resonance, and harmonic chanting to craft a primitive, but potent form of sonic engineering. Not magic, not myth. A science we have only recently begun to understand, hidden in plain sight. This theory doesn't exist in isolation. It weaves into all the methods explored so far. Floating blocks down the Nile, sliding them on lubricated desert paths, lifting them with sand pressure, all could be made easier by reducing weight, if only briefly. If sound altered the stone's effective weight or its frictional resistance, every other method would require less force. Ancient builders may not have needed impossible tools, just layered ingenuity. Sound was the silent partner, not the primary mover, but the silent enabler that made their feats achievable. As we decode their techniques, it becomes clear that they operated not with one secret, but many, each reinforcing the other. And sound may have been the most invisible, yet the most powerful of them all. The anti-gravity sound experiment may never be proven by stone tablets or recovered machines. But the clues are already in our hands. In the walls that whisper, the chambers that hum, and the myths that sing of levitating stones. We stand at the edge of rediscovery, listening again to the echoes of a forgotten science, if we choose to hear them. Chapter 6. The Precision Puzzle Tools That Shouldn't Exist. At first glance, the Great Pyramid of Giza appears as a mass of weathered limestone, but beneath the erosion lies a level of engineering that baffles modern minds. The gaps between its granite casing stones are so tight that not even a blade can pass through. Some blocks weigh up to 70 tons and are polished to near-perfect flatness. The inner chambers and passageways are aligned within a fraction of a degree to true north, a feat modern surveyors would find difficult without laser tools. The deeper one looks, the more it becomes clear. This was not the result of brute labor alone. Something else was at work. The common narrative credits copper chisels and dolerite pounders, but neither tool type could possibly produce the smooth, linear incisions and boreholes found throughout the pyramid complex. The marks are consistent with rotary motion and high-pressure drilling, methods no ancient manual record mentions but that exist plainly on the stones themselves. In the heart of the pyramid, inside the king's chamber, massive granite slabs form a ceiling suspended overhead without the aid of mortar. These slabs were cut, moved, and placed with such precision that modern engineers struggle to explain how this was done using the supposed tools of the Old Kingdom. These stones are not native to Giza. They came from Aswan, over 500 miles away, and yet they were shaped to fit in ways that suggest the builders used advanced geometric planning tools. Even more intriguing are the internal notches and smoothbore holes within these blocks, carved as if by spinning tools with uniform pressure, an impossibility using handheld chisels. Core drill samples from the site reveal spiral grooves that resemble those made by diamond-tipped drills today. It's as if whoever built this structure had access to technology that would not reappear until the Industrial Revolution, if not beyond. On the outer casing stones, many of which have been lost to time or stripped for later construction, the remaining examples show a mastery of leveling that challenges belief. These massive blocks are joined with such fine tolerance that they almost seem fused. The pyramid sits atop a leveled bedrock platform, yet the platform itself shows signs of having been machined flat. Some of the bedrock appears to have been scooped or cut as if by high-speed rotary tools. Geological studies confirm that this was not the result of natural weathering or simple pounding. Even the foundation stones bear straight-line incisions, tight corners, and symmetrical fitting that mimic machine-cut architecture. If ancient tools were solely responsible, we are left with a conundrum. How did soft copper survive repeated impacts against hard granite and still produce clean cuts? Elsewhere in Egypt, Temples such as those at Abu Simbel and Karnak show similar signs of impossible tooling. Blocks interlock in 3 dimensions, with curves that require exact mathematical knowledge and shaping methods far beyond what traditional chisels allow. Even the Serapeum at Saqqara, home to enormous granite sarcophagi weighing over 70 tons each, displays an eerie level of flatness inside the box interiors, far smoother than any rough-hewn chamber. Some boxes appear to have been polished with unknown abrasives or perhaps exposed to high-frequency vibration tools that removed material at a microscopic scale. These weren't rough containers for burial. They were crafted with the same obsessive precision seen in high-tech manufacturing. And yet, no record shows how it was done. The silence in historical texts is louder than any tool strike. Microscopic analysis of the cut marks found on some granite surfaces only deepens the mystery. The grooves suggest consistent depth and angle, indicative of tool-guided precision. Experts have noted that even modern carbide or diamond blades would be required to replicate such incisions. But there is no sign of abrasives, no remnant of tools, no forges or workshops nearby that could produce metal alloys capable of holding such an edge. What remains are marks that should not exist, swirls, parallel grooves, and internal corners that violate the expected limits of ancient metallurgy. Some have proposed the use of lost alloys, perhaps bronze composites hardened through techniques no longer understood. Others have hinted at the use of vibrational cutting, where tools amplified by sound frequencies could weaken the stone matrix itself. The measurement systems employed in the pyramid's construction also reveal something uncanny. The ratio of base to height aligns almost perfectly with pi, and its proportions encode the golden ratio, Earth circumference, and even astronomical data. How could ancient builders, supposedly limited to simple ropes and cubits, know so much? The tools they must have used to measure angles, distances, and alignments down to submillimeter accuracy remain missing. No protractors, levels, or compasses from that era have been found with the level of refinement necessary for such a task. And yet, the angles are precise. The pyramid's corners align within minutes of arc to true north, rivaling modern observatories. If nothing else, their tools must have been radically more sophisticated than we've been led to believe. One possibility lies in the use of metallurgical technology that left no trace. Could they have used bronze tools with hardened edges achieved through repeated annealing, perhaps even alloyed with meteorite iron? Some meteorites contain high concentrations of nickel and other strengthening elements. If such metals were collected, shaped, and hammered over generations, it's possible the ancients developed cutting edges far beyond the known capacity of early metalwork. But the lack of physical examples leaves this theory in limbo. All we have are the marks left behind, marks that tell a different story than the copper chisel narrative. If meteorite-forged tools existed, they were sacred, rare, and likely hidden from everyday use or destroyed to conceal their power. There are also theories involving a lost form of abrasive slurry. Some propose that ancient Egyptians mixed quartz-rich sand with acidic compounds and used rotating copper tubes to drill through granite. The slurry, acting as both lubricant and grinding agent, could theoretically wear down even hard stone over time. But the smoothness of the final cuts, the symmetry of the bores, and the speed implied by mass construction do not support such a slow, laborious method. If slurry was used, it had to be enhanced by something more, perhaps ultrasonic vibration, creating resonance that weakened the molecular bonds of the stone. That kind of technology borders on what we'd consider modern industrial science, yet it fits the visual evidence far better than any traditional theory. Many Egyptologists resist these ideas because they disrupt the established timeline of human progress. Accepting that such tools existed in ancient times forces us to question not just Egypt's legacy, but the entire narrative of technological evolution. The reality is these stones were cut, shaped, and placed with a level of precision only now being replicated with computer-guided machines. If the Egyptians used such methods, they did so without electricity, without steel, and without any written documentation surviving into our time, which raises a haunting possibility that their knowledge was passed down verbally, guarded, or perhaps even erased intentionally. Whatever the reason, the pyramid's construction whispers of a chapter missing from our history books. Adding to the enigma are ancient depictions that hint at tools we cannot identify. Reliefs show workers holding forked rods, tuning fork-like objects, and strange handheld devices never clearly labeled or described. Some appear to be in use near stone blocks or beside acoustic chambers. Are these symbolic representations, or were they visual clues to real tools now forgotten? In a few temple walls, workers are shown not striking stone, but touching it lightly with rods while others chant nearby. It seems absurd by modern standards, yet when combined with the sonic theories explored in the previous chapter, these depictions start to suggest something more complex. Tools that worked in tandem with vibration, frequency, and geometry rather than brute force. The implications stretch beyond Egypt. Across the world, in Peru, India, and Cambodia, ancient structures show similar feats of impossible stonework. Interlocking blocks with no mortar, cuts too fine for iron tools, and drilling evidence in premetallic cultures. Could these civilizations have inherited a legacy from an earlier epoch? One lost to cataclysm or erased by time? If so, then the pyramid is not just a tomb or a monument. It is a blueprint, a fossilized machine, and a record of lost technology. In its geometry and scars, it preserves knowledge we've only begun to recognize. The question is no longer whether the tools existed, it's whether we can rediscover them before they vanish from memory forever. So the mystery of the tools lingers like an echo trapped in granite walls. What shaped these stones with impossible precision? Where did the knowledge go? Who wielded it? And why has it remained hidden for thousands of years? Each uncut groove and impossibly flat surface is a riddle left by ancient hands, asking us not to look forward for answers, but backward. Not toward progress, but toward loss. Somewhere, between erosion and myth, a truth waits buried beneath the dust of dismissed ideas. And perhaps the pyramid, with all its silent geometry, is still trying to tell us what we've forgotten. Chapter 7. The Blueprint from the Sky, a design only seen from above. There is something unnerving about the geometry of the Great Pyramid when viewed from the sky. Its lines are too perfect, its cardinal alignment too precise, and its scale too vast to have been created through trial and error from ground level. From above, the layout reveals a symphony of proportions, golden ratios, and star-like positioning that only makes sense when the structure is taken in from a great height. This raises a disturbing question: who or what was looking down? Ancient builders working with nothing more than basic tools should not have been able to lay out such a blueprint with this level of symmetrical mastery. The possibility emerges that the pyramid's plan wasn't solely conceived from the ground up, but rather from the sky down. The implications are profound. Whether this was done through elevated platforms, balloon-like structures, or lost aerial surveying methods, it suggests knowledge of perspective far ahead of its time. When comparing ancient pyramid layouts to modern satellite imagery, another detail comes into focus. The surrounding pyramids are not random in position but part of a celestial geometry. The three pyramids at Giza mimic Orion's belt not just roughly, but astonishingly close in proportion and angle. This design precision implies an understanding of how their alignment would appear from a height, if not from orbit. Could ancient priests, engineers, or rulers have possessed maps or charts created from a sky-based viewpoint? A myth among some traditions speaks of gods who descended from the heavens and mapped the world for man. If these were not merely symbolic deities, could they have been advanced beings with aerial capabilities, or remnants of a prior civilization that had mastered rudimentary flight or surveying from above? Some artifacts hint at strange devices that defy the timeline we've come to accept. A peculiar relief in the Temple of Hathor at Dendera has long stirred debate due to its odd depiction of what looks like a bulb or balloon-like apparatus. While the mainstream view dismisses these as symbolic or religious metaphors, alternative researchers argue that these images might hint at technological devices once used in forgotten aerial methods. The concept of lifting individuals or instruments to high altitudes would have made such architectural surveying plausible. Even something as simple as tethered hot air devices, if discovered and utilized thousands of years earlier than expected, could revolutionize our understanding of how such vast land-based designs were conceptualized with sky-level precision. The Great Pyramid is not just an isolated structure. It is part of a grid. When measured against other ancient monuments across the globe, it falls into startling alignments, particularly along what researchers have labeled the Earth Grid or the Great Circle. Sites like Easter Island, Machu Picchu, the Nazca Lines, and Angkor Wat fall into geometric alignment with Giza, as if part of a grand cartographic network. From the ground, these connections are invisible. From the air, they form a tapestry. How would ancient Egyptians have known where to place their monument to align with lands thousands of miles away? Unless, perhaps, they inherited this knowledge or preserved it from predecessors who had already mapped the world from above, perhaps long before history remembered them. One of the most haunting aspects of the Giza Plateau is its interplay with light and shadow. During specific days of the year, equinoxes and solstices, the sun casts shadows on the pyramid that highlight hidden lines and internal structures. When seen from a high vantage point, these temporary markings trace out designs that remain unseen at ground level. Some researchers believe that these shadow maps reveal internal passageways or secret chambers not yet discovered. It's as though the structure was meant to be periodically decoded by sunlight, visible only to those with an elevated view. If this is true, then the pyramid was not merely built, it was programmed to be read from the sky. Consider the internal chamber layout of the Great Pyramid. The king's chamber, the queen's chamber, and the so-called subterranean chamber are not aligned arbitrarily. When rendered in 3D models and examined from a vertical view, the chambers form a configuration resembling constellations. The shafts that extend from these chambers align not just with specific stars, but do so with a precision that suggests deliberate stellar navigation. These celestial alignments were not observable from within the dark, narrow shafts themselves, but from calculations requiring a vast view of the heavens. The pyramid appears to function as a celestial machine, its layout resonating with both the stars above and the forces of gravity below. Again, this implies a God's eye perspective in its design. Across ancient Egypt, the motif of the eye appears relentlessly. The eye of Horus, the all-seeing eye, and the depictions of winged deities watching from above fill temple walls. These symbols may have more than mythological meaning. The eye, often positioned above pyramids or inside pyramidal shapes, may have symbolized a source of oversight, mapping, or surveying from an elevated realm. Perhaps these were not just metaphysical symbols, but literal reminders of a once visible presence, observers from the sky. Whether divine, extraterrestrial, or human, these beings might have overseen the construction or passed on methods of mapping from a perspective lost to us today. In the deserts of Egypt, archaeologists have uncovered large raised mounds of earth that do not fit natural geology. Some suspect they were artificial platforms, launch points, or observation towers that provided an early form of elevation. From these heights, basic surveying tools like sightlines, ropes, and measuring rods could produce surprisingly accurate layouts over vast areas. But even this raises more questions than answers. How were such platforms constructed to endure? How were measurements transferred over miles without deviation? And most importantly, why were they later abandoned or buried? If they held such critical roles in planning one of the world's greatest architectural feats, why do they exist only in fragments? Further fueling this aerial theory is the sheer volume of pyramid simulations and reconstructions now performed through drones. As modern researchers attempt to recreate the planning of the Great Pyramid, many find themselves relying on aerial drones and sky maps to simulate what could not easily be seen from the ground. Ironically, this need mirrors what ancient builders might have encountered, an overwhelming task that almost demands aerial oversight. When modern tools naturally replicate what ancient tools could not, it begs the question, were the ancients solving the same visual problems with technologies that are now lost? The precision of the base platform of the Great Pyramid is yet another baffling feature. It is almost perfectly flat, with variances within mere inches across a massive area. Such foundational exactness suggests that the design was pre-calculated from an overhead layout before a single block was placed. The ancient surveyors would have needed to know where every corner would meet, how the layout would settle, and how to correct for curvature or tilt in the Earth's surface. From the air, it becomes much easier to understand why such accuracy was needed. The base was not just structural, it was part of a map, a grid, a message inscribed into Earth's crust. Perhaps the most unsettling idea of all is this: what if the Great Pyramid was not meant to be seen from the ground at all? What if its true purpose was visible only from the sky, from ancient flyers, celestial watchers, or even distant orbits? Some researchers suggest the pyramid was a beacon, a signal, a timestamp visible from above. Its angles, materials, and internal resonance may have served as a transmitter, a landmark, or a calendar inscribed in stone. If this is true, then humanity has been studying it from the wrong angle for millennia. We have wandered its chambers, measured its base, and scanned its walls. But perhaps only now, with eyes in the sky, are we beginning to see what it was truly meant to reveal. The chapters before this have walked through the stone-moving techniques, lifting mysteries, and strange architectural anomalies. But only now, when stepping back, far back, does the complete picture emerge. It is a picture only visible when all pieces are assembled and viewed from the heavens. The ramps, the precision, the sonic anomalies, the stone manipulation, all serve something bigger. A blueprint not designed in haste, but with cosmic perspective. If the builders did not fly, then they worked as if they could. They built for the sky, and the sky in turn remembers them.